Hi everyone, welcome to our presentation. Firstly, let me introduce you to our background and definition of the business use. Though customers can search the flight information and weather information respectively online, it is not convenient for customers to open different websites and may also be confused with different airlines information. In addition, airlines do not supply detailed real-time flight and weather information to their customers, but some customers may concern about those information. We aim to design a quick, overall, and brand-exclusive searching engine for airline companies. This searching engine can help customers, airport service staff, and airline companies to track the latest flight and weather information once users fill in their flight numbers. Next is our data source specification. Real-time flight data is provided by Aviation Stack API. We extract 17,000 real-time domestic flight data, and real-time weather data is provided by CheckWX API. 169 real-time weather information were extracted for 169 domestic airports.
Compared to the ETL, we think the ELT is a more appropriate way of implementing our project. Since the API data we retrieved are relatively tidy, for the EL process, we store the flight data into SQL and the weather data into MongoDB. For the transform process, we transformed some data to be more readable and built file data warehouse based on features we needed. Lastly, we designed two-page web page and constructed search engine on them using Flask API.
This is the coding of our project. Firstly, we acquired the key of weather API and use Python to look the weather information. Secondly, we make a list of tables to include all observation of US airports. Then we set up PyMongo and MongoDB to store data. We have inserted 169 weathers and 1,162 documents. Last step is to double check our data set.
Thank you. First, we use APIs to extract flight data from Aviation Stack website. We get all the flights depart from JFK to EWR. The flight data contains airport names from both departure and arrival locations, delay informations, time zones, scheduled flight time, gates, terminals, and baggage information. And next, we set up SQL database and connect it to the local host and create 4 relational tables of flight, trip, departure, and arrival information. Then we insert data into 4 tables in SQL database.
Thank you, Mina. Now I'm going to explain how we conduct an ELT pipeline to merge data from different databases together. As explained before, we have 2 databases. One is MongoDB and another one is PostgreSQL database. So in this cell, you can see we're trying to put all the data into the data frame from MongoDB. And here is the outcome. And you can see the data contain all the information, but there are some columns we don't really need. So in Excel, we're going to clean the data. Only choose the column we need and then put it into the new data frame. But the data frame is still not clean enough because there are some duplicated. So this cell is to change the type of data into timestamp data type and only keep the latest data. And as you can see in the next cell, we double check that there's only one data for each location. And next cell is to change the column's name because the project involves front-end design. We need to make sure that user can understand each column easily. And now we succeed in cleaning MongoDB's data. Next cell is pretty much the same. We collect the data from PostgreSQL database, store it into the Panda frame, change the column's name, and next is to merge 2 data frames together. We use inner join method and group by arrival airport ID. So in this way, we succeed in using ELT pipeline to put all the data together and then store it into the CSV file for future use.
Thank you, Tiancheng. This is the web page of our search engine. We built this search engine using HTML, CSS, and Flask API. We expect our customers to input a date, departure airport, destination airport, as well as some optional fields like the flight status and the airline company. For example, if we enter the EWR to San Francisco at the date of the April 27, we get a list of flights and weather information. This is displayed as a different. And the operation behind this procedure is supported by the Flask API. First, the Flask API will get user input and then use those inputs to filter our data warehouse. And then finally, we send a filtered data frame to the web page, which will be displayed as a results page for users. So this is all about the search engine, the interactive user interface. Next, we will go back to the slides.
Thanks, Zhongwei. And here I'm going to introducing data governance policy and the cost limitation. For piracy, because we are using public flight and weather information, the data set does not involve any personal data or any sensitive data. And also the data is collected from legal API, and we check their website. As long as we pay for the API license, there's no any restriction of data using. We try to use a free version of API, but there are some limitations. For example, in free version, we can only get like 13 rows of data, which is not enough for this project. So we update the version to paid version, which costs around like $50 for a month. Other than this, all the cost is free or covered by Columbia University student account.
To assess the success of our search engine, we will evaluate from two perspectives. To ensure the customer experience, we believe that if a success, our search engine's query response time should less than 1 second. 100% query results should comply with real situation. Changed information can be updated within 1 minute. And content of information should be very brief and clear that customers' average time spending on one site should less than 30 seconds. To measure the operation success of our search engine, we will expect at least 80% customer retention rate and 40% growth rate of user and website visit number.
There are many limitations about our API and interface. First, we have very limited API choices of our topic, and we have limited data that we can get from API. Also, we need more advanced tool to get real-time information from all the flights and airline informations. And then there are very limited time and ability for us to create attractive users interface of our search engine. In conclusion, our users can get real-time flight information and weather information in our search engine. And there are 3 recommendations for this project. First, we can include more flight information and airline information because we have very limited information due to API limitations and other external factors. Users may want to see more flights and airlines information when using our interface. And then we should also improve our interface to include more related information such as news and creative designs. This can attract more users and provide them with news and our real-time flights in the beginning side. And finally, we can create a text or email subscription for users to receive real-time alerts for their flights, and customers and their families can receive daily information and arrival information at the first time. Thank you.